Chapter 12, Groundwater and Wetlands. Meet your drinking water. Holes in earth materials. Groundwater systems, a case study, the High Plains Aquifer. Groundwater quality, and an introduction to wetlands. Meet your drinking water. Only 3.5% of Earth's water is fresh water. Most of the water is locked up in the ice sheets of Antarctica and Greenland. Most of the remaining fresh water is in the rocks and sediment below Earth's surface called groundwater. Groundwater is a primary source of water for agriculture, industry, and municipalities. California accounts for 1/5 of all U.S. groundwater usage. Recent years of drought have diminished surface water supplies, requiring more use of groundwater. This graph shows the change in the usage of groundwater in the last 60 years. The Central Valley in California is one of the most productive farming regions in the world, and thus uses a significant amount of water. Groundwater supply is decreasing because the influx of water is not enough to replenish the amount that is used. The California Water Project manages the distribution of water in the state. The map shows where water is moved from north to south through reservoirs, rivers, canals, pipes, and tunnels. The Sustainability Groundwater Management Act was passed in 2014. It requires water users to develop groundwater sustainability plans. The plans must include protections against the overusage of groundwater, including lowering water levels, degradation of water quality, contamination by seawater, subsidence, and impacts on surface water. Hydrogeologists will oversee the development and implementation of the plans. There's more water underground than in lakes and streams on Earth's surface, about 70 times more. Most groundwater is in billions of tiny spaces between mineral grains or in narrow cracks. The amount of groundwater at any location depends on the porosity and permeability of materials beneath the surface. The porosity is the proportion of a material that is made up of spaces. For example, if half the total volume of rock is pore space, the porosity is 50%. This depends on size and arrangement of the grains. The better sorted, the higher the porosity. As the material grains compacted or cemented, porosity decreases. Porosity is greater in unconsolidated materials like sand, gravel. They're more porous than sandstone or a conglomerate. The groundwater that can drain from a rock or sediment is called a specific yield. Specific yield is porosity minus specific retention. The specific retention is the water on the surface of grains that will not flow through the material. That is, it's stuck on the grain surfaces. The specific yield of fine-grained material is low, even though their porosity can be high. The permeability is the capacity of water to flow through earth materials. Water can flow readily through materials with well-connected pore space or many fractures. Connections between pore spaces are wider in coarse-grained material like gravel than fine-grained materials like sand. High permeability does not always go hand in hand with high porosity. This is an above-ground formation that's representative of an underground aquifer. Groundwater is stored in bodies of rock and/or sediment called aquifers, which are composed of sufficient saturated permeable material to yield significant quantities of water. Aquifers can form in a variety of geologic settings. They can be composed of sands, gravels, sandstone with good porosity and permeability, and fractured rocks. These maps show various aquifers located in different states. What type of aquifer is in your state? Aquifer quality: high porosity and permeability. Most productive aquifers are found in unconsolidated earth materials. 80% of all groundwater within the U.S. comes from sand and gravel aquifers. Aquitards, which are low permeability materials such as clay, shale, or unfractured igneous or metamorphic rock that act as a barrier to water flow. There are wetlands and springs present where the water table lies at the ground surface. Wells become dry if they don't penetrate far enough into the saturated zone of the aquifer. In general, the water table follows the shape of the land surface. The top of the saturated zone is the water table, and it is highest under the hills and lowest in the valleys. Water flows down the slope of the water table, the hydraulic gradient, when the water table intersects the land surface. A stream, lake, or a spring will occur. A confined or an artesian aquifer is enclosed above and below by impermeable materials. Water can only enter the well through the exposed rock layer, which is the recharge zone right in here. This is where there's an artesian well. Water is under pressure. Water can flow without pumping until water table equals the elevation where the water is withdrawn. Inflow or recharge versus outflow or discharge. Especially important issue is the southwestern states. Recharge can occur through infiltration of rainwater or streams. Losing streams, or flow over ground in dry areas and lose water into the groundwater supply. Recharge can also occur from stored groundwater present from a wetter time in the past, for example, water that precipitated into the ground when the last ice sheets melted. This is non-renewable water. Gaining streams gain water from an area with a high water table. This is a form of discharge, not recharge of groundwater. Losing streams lose water to the saturated zone of an underlying aquifer or to the unsaturated zone in dry regions. Water enters gaining streams from the saturated zone of an adjoining aquifer. Groundwater can reach the surface at springs and wetlands. Springs form where there are fractures or cave systems intersect the land surface, or wetlands may form where several small springs distribute water over a region underlain by a low permeability material such as clay or shale. B shows the cave systems and C shows the wetlands. Look at these graphs. Which one do you think is a gaining stream? Why do you think that? How does groundwater interact with oceans? In coastal regions, fresh water is found floating above a denser layer of salt water. Salt water infiltrates the ground just like fresh water. Where freshwater layer meets the coast, it flows into the ocean. In coastal cities, fresh water can be extracted from the freshwater layer, but if it is extracted faster than it is replenished, salt water can flow into the wells. The consequence of human actions. Rapid population growth equals a greater need for groundwater. The groundwater overdraft. The supply cannot replenish as fast as we extract it for human use. A decline in the water table. The water table surrounding a well can decline if the water is pumped out too fast. The surface of the depleted water table forms a cone of depression around the well. Trying to pump groundwater is like sucking up a spilled drink from a table. No matter how big a straw you use, most of the drink stays on the tabletop. Some of the world's largest cities have experienced subsidence. Over 12,000 square kilometers were affected in Houston. Groundwater withdrawal caused more than over 30 feet of subsidence in some parts of the San Joaquin Valley since the 1920s. About 2/3 of all fresh U.S. groundwater pumped from aquifers is used for irrigation, much of which occurs in the Great Plains, like Texas, Oklahoma, Kansas, Nebraska, and all their neighbors. This was originally dubbed the Great American Desert, unfit for cultivation. Irrigation for the Great Plains is mainly taken from the High Plains Aquifer. Sand and gravel with some underlying sandstone, an open aquifer, partially recharged by rain and snowmelt. The water table is typically less than 100 meters below the surface. Today, the High Plains Aquifer produces more water than any other groundwater source in the entire nation. More than 170,000 wells draw water from the aquifer. The largest area of irrigation sustained cropland in the world. There is no contemporary source for the water to recharge the whole aquifer. Most of the water in the aquifer entered it during the last glacial maximum, which was a lot wetter climate. This is fossil water. It's being used up faster than it's being recharged. And the water table is dropping over much of the aquifer. The High Plains Aquifer. The decline of water table by about 1.5 meters in the darker area. A rise in the water table of about 3 meters, the yellow parts. The groundwater overdraft has caused a drop in the water table of up to 70 meters. Much of the agriculture in the middle United States relies on water from the High Plains Aquifer. What are the long-term implications if we continue to use large volumes of groundwater for irrigation faster than it can be replenished? Although natural groundwater is not pure, in the United States, it typically contains few chemicals in sufficient quantities to cause harm. Under certain conditions, harmful elements like arsenic, mercury, can contaminate drinking water. In Bangladesh, there's widespread groundwater contamination by arsenic. It may end up being the worst mass poisoning in history. Well, Bangladesh is the most densely populated nation in the world. It's also one of the poorest nations in the world. And people used to drink surface water contaminated with pollutants until wells were drilled in the late 1970s. One problem that Bangladesh has is that because they're poor, they needed to use the rainforest that was up in the hills. They needed to cut it either for places to plant their crops or just for the money for the wood. Now, the rainforest is gone, and there's not that vegetation that absorbed a lot of the precipitation that occurs there. Bangladesh has a big flooding problem, and this is partially why. There are high concentrations of arsenic in the water that were discovered after the wells were already in use. On the map, the darkest greens are the highest proportion of wells contaminated by arsenic. The worst affected wells are south of the confluence of the Ganges and the Brahmaputra rivers. These two rivers are sourced from the Himalayan foothills. The rocks there contain unusually high natural concentrations of arsenic. Half the population of Bangladesh, 60 million people, may be exposed to arsenic levels above the World Health Organization standard. In the United States, the standard for arsenic in drinking water is 10 parts per billion, or 0.05 milligrams per liter, as set by the World Health Organization. In Bangladesh, the standard is 50 parts per billion. Some wells in Bangladesh have levels as high as 2,000 parts per billion. Do you think they should be drinking the water? Some people don't have a choice there. It's all they have. Arsenic levels tend to be higher in the western states that have more igneous and metamorphic rocks. This map shows the range of maximum arsenic concentrations for at least 25% of tested samples. Arsenic in groundwater is a result of chemical weathering processes. Nature can cause contamination of groundwater, but it's mostly due to human activities. The sources of human and natural contamination can be from source points and non-point sources. A point source can be specifically identified and located, for example, a leaking gasoline storage tank. A point source, once identified, can be shut down. Non-point sources occur over a wide area. Examples of human contaminants in groundwater are things like benzene, nitrates, pesticides, fertilizers, microbes from untreated human and animal waste. Potential sources of groundwater pollution in the United States. Agricultural operations. It produces animal waste, and annually the application of millions of tons of fertilizer. And all this permeates through the soil into the groundwater. Thousands of metal and coal mines. There are 3,000 landfills and thousands of illegal dumps. Everything leaches through the soil into the groundwater flow. There are over 1 million malfunctioning septic systems and 5 million storage tanks for gasoline and chemicals. The Ramsar Convention, a treaty that was intended to preserve and protect more than 321 acres of wetlands around the world. 12 of the sites are in the United States. To be a wetland, an area must be saturated with water and have poorly drained soils and specific types of plants. There are two types, coastal and freshwater. Marsh here and a tidal marsh are continually inundated with water. They have no woody plants. A swamp is a wetland dominated by woody plants. Wetlands must meet the following criteria. The hydrologic conditions. Water must be present on the land surface or soils in root zone must be saturated during the growing season or longer. Hydrophytic vegetation. Specific plants that are water tolerant and grow under wet conditions like cattails, wild rice, willows, sawgrass, mangroves. These types of plants must be present. Hydric soils, poorly drained soils that exhibit anaerobic conditions during the growing season. Anaerobic, without oxygen. In the lower 48, the largest wetland areas are in Texas, Florida, and Minnesota. Outside of Alaska, wetlands have declined by about 55% since the 1600s in the United States. About 10% or less of the original wetlands remain in California, Ohio, and Iowa. The losses are due to draining to support agriculture or draining and infilling for urbanization and development. Why should we care? Really, why should we? Wetlands actually perform many functions in the environment, such as improving water quality in rivers by filtering out sediments and contaminants, by providing breeding grounds for fish and shellfish, which support commercial fishing, providing ecological habitats for migrating birds, modifying the effects of flooding by slowing runoff and providing recreation for humans. Think about oysters. Oysters, a type of shellfish, they're bivalves, filter 50 gallons of water every day. They're cleaning the water. We don't want to kill them. The Florida Everglades. The River of Grass experienced a huge loss of wetlands due to population growth and urbanization. Development in the early 1900s had 4 goals: dike it, dam it, divert it, and drain it. They lost 50% of the original wetlands, destroying fish and wildlife habitats. There's only one Everglades in the entire world. The wetlands were replaced by agricultural sugarcane, and expansion of coastal cities further stressed the ecosystem. Think of all the sewage from the cities that has to go somewhere. Attempts to partially restore the wetlands are ongoing and have been ongoing for many years. This shows the land use patterns in southern Florida from 1900 to the 1970s. The original wetlands, where marsh and sawgrass, were replaced with agriculture dominated by sugarcane. Southern Florida drainage basin. Water flows down a slope 3 to 6 centimeters per kilometer.